In this video, we are going to review scalar and vector quantities and some terms that go along with those. So have a look at those learning goals. And let's move on. So let's first look at scalar and vector quantities. A scalar quantity is something that only has a magnitude. So it only has units. So think of magnitude as being your units. So a can of pop has a volume of 355 milliliters. The 100-meter sprint is 100 meters. So just the units. A vector quantity, which is what we deal with a lot in physics, has a magnitude and a direction. So for example, Bowmanville is 80 kilometers east of Toronto. And it's that east value that is actually what's making it a vector quantity because we have that direction. Okay? So in physics, anytime you see that little arrow over top of the symbol, for whatever variable it is we're talking about, that's telling you that it's a vector quantity. And so your answer needs to have units and a direction. So let's look at some key terms. So distance. Distance is a scalar quantity, and our base unit is the meters. You can have other units, of course, but generally when we're talking in physics and we're doing math, we want things in meters. So it's the total length of the path traveled by an object in motion. So if we look at this picture, it says, what is the total distance traveled if you drive to the store and back? So you would drive 3 kilometers to the store, 3 kilometers back, meaning your total distance traveled is 6 kilometers. So that's distance. Distance, it doesn't matter what direction you traveled, nothing else matters. Just how far you actually went, the total length of that path. Position, on the other hand, is your distance and your direction from a particular reference point. And we always have to state what the reference point is. And it's a vector quantity. So if you're at the store over here, you are 3 kilometers from home. So the from home part is our direction. It doesn't have to be an east, north, south, west direction. It can just say from a particular point. And that is our position. So our position when we're at the store is 3 kilometers from home. Displacement is the change in position. And it can be calculated using this formula. So it's just a difference formula. So you take the final and you subtract the initial. You're going to see that formula a lot in physics. So if we were to go back to kind of that first example that we were looking at, and you walked from the home to the store and then back, if home is our reference point, you've actually have a zero displacement because you returned back to where you started. And we don't really have to say a direction here because home would be our reference point. We're going to look at lots of examples where we talk about actual directions. So let's look at this example. So a dog is practicing for an agility competition. She leaves her trainer and runs 80 meters west to pick up a ball, carries the ball 25 meters east to drop it in a bucket. What is the dog's displacement? So generally when we do this, we treat west as being negative and east as being positive. You can really choose whatever you want, but those are the general forms. We use north and east as being positive because if we kind of think about it as a graph, this would be our positive area, and we treat south and west as negative because this is our negative area. So that's just kind of why we do that, but again, you can use whatever you want. So if we put these numbers in using west, we're going to put it in as negative, and our east as positive, it would look something like this. So we would have 25 meters. I'm just going to put the positive one first. It doesn't really matter. And then we would subtract 80 meters. So we would get 55 meters. And then in our final answer, we're not going to leave it as negative because they didn't actually travel in negative. That negative is actually telling us that we traveled 55 meters, or the dog, sorry, not us, that the dog traveled 55 meters west. And so a displacement always has to have units and a direction. So your answer needs to have two parts. And of course, it also has to be rounded to the correct number of sig figs. So we'll treat that as 2 sig figs. Another way to represent vectors are to draw scale diagrams. And so you use a scale. Generally, we use 1 centimeter to 1 kilometer or 1 centimeter to 1 meter, whatever you need. You do have to use a ruler to do this because you do have to, in fact, measure. So make sure you are using a ruler. And we always draw vectors tip to tail. So what that means is if we look at this drawing down the bottom, so we have this 5 meters, let's say, in the east direction, and then another 10 meters, so we draw them tip to tail, and then we can draw our resultant vector from the starting point to the end point. So that's actually how they would have gotten this diagram. So let's look at where we draw a vector scale diagram. Now, because it's hard for me to show you using a ruler in this video, I'm going to use grid paper. You would use a ruler and you would draw. So if we read this, we're going to a friend's house. You have to pick up pizza before going over. From your house, you walk 350 meters north to the pizza place and then 900 meters south to your friend's house. What is your total displacement? And it should say from home here because we should be talking about what is our reference. So we do want to set up our scale. So you're going to be using a ruler. So let's say you're going to say you've got 1 centimeter is equal to 100 meters. I'm going to use blocks just because it's going to be easier for me. So I'm going to choose my starting point and I'm going to try and draw. So there's 1, 2, 3, 3.5. It's going to be a pretty approximate for me because I'm using a grid. So that's our first one. And then from there, we want to go down 900 meters. So let's go ahead and draw that other vector in. Again, if you're using a ruler, it obviously comes out looking a lot cleaner than that. So let's add our resultant vector in. So our resultant goes from where we started down to where we ended. And then what you would do is you would use your ruler, or you would, in this case, you would count your blocks. So if we count our blocks, we are going 1, 2, 3, 4, 5.5 blocks. So we've got a displacement of 550 meters south. So that's another way of doing or figuring out your displacement. You can draw a scale diagram. So here's the end of our video. So just check the learning goals. I will be able to explain the difference between scalar and vector quantities. Hopefully you're good with that. You'll be able to explain motion using the terms distance, position, and displacement. Hopefully you're good for that. And you'll be able to draw vector scale diagrams because those are going to come into play again later in the unit.